Hi my friends. Some of my friends, tutorial friends, were asking me how to create a GEAR HOB like this one with more than one thread. This one has only one thread. This is presented in detail in my tutorial number 159. The name is GEAR HOB. I'll present you the new HOB with multi-threads, but first I want you to know what is multi-threads. Yes, this is why I opened here a screw which was presented in my tutorial number 016. The name real threads. What means this? This means that we don't have a texture here, but we have a helicoil, real helicoil, as you can see. Yes. From this situation, I move the end part before the coil, and now we have a screw without a thread. Yes, no thread. More than this, I kill everything is below. We create now a new real thread. A new real thread. We create a sketch in the plane XY. F7 and the profile, which is very simple. You can watch the tutorial number 16 to see how to do, because there is explained very well. Now I don't explain many things. Look there, tutorial number 16, and you'll find out how to create this sketch. The angle is 60 degrees and the symmetry is created by making equal these two sides. I project as center line the axis Y. Yes, this is the projection, escape, and then I place diameters. As you can see, this one is 20.752. You can check the mentioned tutorial. This is the pitch divided by 2. The pitch is 3 millimeters because the diameter here is 24. I also project as a construction line this line to place on the same line this point with this line, and to create a constraint for the end of this. Good. What about this dimension? The diameter here is the pitch diameter, 22.051. Check the tutorial to see better. And these points are on the sides. Yes, good. Now you see fully constrained is this profile. Finish sketch, and we apply coil. By using the pitch value, I forgot to show you this great table with some definitions. Pitch is this value, 3 millimeters, which can be used. Double click on the sketch, and instead of 3 millimeters I place the text pitch. You see, is accepted, of course. Finish sketch. Now again coil. We select here 12 revolutions. The profile is already selected. You see, this is the only closed contour in a sketch in this model, unconsumed. So, taking a look here, cut, we apply OK, and now we have the coil. Yes. Now I make changes. This is why we use Inventor, because it's a parametric software. Double click, and I apply a rectangular pattern, selecting everything here, the direction in the other orientation of 3. You can place here more than 3 with the distance of the pitch, capital P we have to use. Okay, so we have 3 profiles. Finish sketch, nothing is changed, but now when I double click here and I select pitch multiplied by 2 and I change this by selecting 2 profiles. Okay, I have I have a thread with 2 threads, 2 starts. Yes, this is one start and the other is here, the other start. You see better here. More than this, we can double click on coil. We apply 3, the value 3 here, and instead of 2 profiles I select all the 3. 1, 2, 3. Okay. F6. Now we have 3 threads. Yes. This means that when we make a rotation, the nut will move up or down 3 times the pitch, not only 1. We can observe that the angle of the coil is 3 times greater than with 1 thread. Yes, you can make something else to see what is this about. I erase the selected 3 profiles and I select only one, but the pitch is multiplied by 3. Okay, you see, this is what the worker at a lathe does when he is asked to create a multi-thread thread. Or this is the first one. I disable this and I select 2, 1, 2. Okay, and we see what the workers make. He has created the second thread by moving the cutter with 1 pitch, and when I eliminate the selection and I apply 3 selections, okay, then we have a full 3 threaded thread. I hope you understood this. This is what we'll do with the hob. Yes. Good. First thing first is to study the parameters table. If you go back to the tutorial number 159, you see this table, how it was created and so on. Here we add a new parameter with the name and threads. Yes, look careful. T is capital and the plural threads I write here. The unit is unitless. The number of threads is unitless. And here is 1 UL, unitless. Okay, now we have a new parameter. The others are modulus, height, and so on. You have to look at the creation of this hob. The drawing is here, and you have to take care because the threads number is here n with the symbol n, but you have to change it in I'll do this. I'll change in n threads. Yes. Okay, you see the new parameter created by us with the value 1 UL, of course, unitless. Good. Let's go back to the object. We apply here move AOP marker. Yes, and we see only the revolution feature and the coil feature. The coil feature is based on this sketch. You see this sketch with this, and you take a look there and you'll see what is the definition of this profile. Double click here, shows us axial pitch divided by 2. This is this 6.283. Okay, and not 60 degrees, but alpha multiplied by 2 the rec angle, because this is from gears, not from threads. Okay, what should we do now to create more than one thread? Very easy. We apply a rectangular pattern, we select this and the direction to the left, okay, to the left, 3. You see 3 profiles with the distance as the parameter axial pitch. Yes. Okay. Finish sketch. Nothing changed because we worked only on the sketch, not on the coil feature. Double click and we make another selection, which is 1, 2, 3, and the axial pitch is multiplied by 3. Okay, you see the result. Yes, the angle is 3 times than the angle of one pitch. To go further, we can change the value of number of threads from 1 to 3, if 3 is the number of actual number of threads. We go to the next feature, which is the channel, the perpendicular channel, but now it has another angle. It is not 2.2 degrees and 1 minute, but is 3 times the value of here. So we know what is the sketch, no problem, and we change the coil. The coil is with the angle depending on the pitch. The pitch, you know what I mean. I mean that 10 meters, I don't know, length of this channel pitch. Now, because of the 3 threads, we have to divide this by n threads. Yes, divide it to shorten this length, which means to increase the angle, of course. Okay, F6, and you see this is clearly with another angle. Look at the angle which is perpendicular on the coil. F6, excuse me. Now we can go to the end, my friends. Go end of part to the end. We wait a little because all the next features are recreated and we have the new model. There are some things which are not in a good situation. This cuts. You know, if you look at the tutorial, what is this about? We can modify, we can eliminate the cuts which were good for a hub with one thread. So we select from the work plane to work plane. This is what we want to eliminate. Cuts on one side and cuts to the other side. Delete. With all sketches, no problem. Okay. Well, this is the new model. We have to change here by adding the number of threads. We do this by editing the sketch. In the sketch we edit the text. In the text we add threads equal 3. Okay. Finish sketch, and we have everything in good presentation. Of course, you have to make cuts on both sides to have a tool as in the tutorial. Some of you who are more interested in this particular model can take a look at my iLogic tutorials and see how to make a program in Visual Basic which presents here a table with values of modulus, of number of threads, and also other parameters which are presented here in compatibility. Of course, you change the modulus, you change the number of teeth, and you make this by using the standards, of course. You select here another module, and this is changed automatically. I think that this is enough for you. But I want to mention something. By increasing the number of threads, you obtain a lower precision, but you increase the efficiency of the machining. You have a shorter time to obtain a new part, but you will always have to reduce the feed per revolution of the workpiece. Another restriction, for the sake of precision, is to avoid the divisibility between the number of teeth of the gear to be machined and the number of threads or starts. For example, if the number of teeth is even, you have to choose either 1 or 3 starts, but not 2. Well, that's all for today. Thanks for watching. Bye bye.